Yeah, good evening, everyone. Session again, so let's start off. Chalo, cams on, everyone. My voice is clear, right? I am in my hometown actually, so there is a net issue here and this Wi-Fi problem. Should be fine. So last class we are doing this bulk question. So we did some basic differentiation last time, just the identities and that 6-7 basic formulas. So we'll take it to the next level today. We have something called a chain rule. Others, you need to keep your cams on. One second, why people are so chilled out actually? So what is this chain rule? Suppose if you're differentiating a nested function, matlab a function inside a function. So let's say d by dx of f of g of x, right? So this can be written as, I'll give you some examples. So f dash g of x into differentiate that function inside. So whenever you differentiate a nested function, you first differentiate the whole thing and then you differentiate whatever is inside. What do you mean by that? Let me take some examples. There's a best way to learn this. So listen carefully. You're confused, ask me. I'll give you enough examples that should take care of it. For example, if I give you d by dx of sine x cube. Now, if you see, right, this does not belong to any standard formula that we have. Guys, you all have to be on time. Huh? You guys are coming 4-5 minutes late, and once you start the class, then you won't understand the rest of the class. Don't make this a habit. Venkatesh, Ritu, keep your cams on. So here, what is happening? See, so here the function is x cube is one function here. So how do you differentiate this? So first thing, what do you have? Sine of a function. So forget about whatever inside. So what is sine ka differential? Cos of the function, and then whatever is inside, that is a function differentiated again. So that will be cos x cube into x cube ka differential is 3 into x square. See how we did that. Let me take one more example. Suppose if I have d by dx of cos. Now the formula for cos is what? Minus sine x. But here it is cos of something inside. It is not x. So here this is my function. That's basically my g of x. So this is cos of a function. So cos ka differential, first of all, this is how you see. You're starting with what? Cos. I don't care whatever is inside. So cos ka differential is minus sine of the function. And then since inside it is not x, whatever is there, differentiate it. So this is minus sine 5x. 5 comes out and this will become dx by dx. Dx by dx is nothing but 1. So minus 5 sine 5x. Have a look at this. Let me take one more example.
So over here we differentiate both sine and x, right?
Where, which one?
The first one.
The first one, it is sine of x cube, right? The first differentiate sine ka term. So sine is what? Cos x cube, right?
Yeah.
Now inside whatever you have, differentiate that again separately.
Okay.
Because this is a function inside a function, right? Here sine is the f of x, and then x cube is g of x.
Okay.
This, right? It comes with practice only. So just listen to a few examples
This
and then
is
we
the
will do more.
product rule. This is the product rule. No?
This is not product rule. Arey, this is not sine into x cube, God.
Yeah,
Sine x
right.
cube tha. No. So let me take one more example. Let's say if you have d by dx of root x square plus 1. I'll just write this as x square plus 1 whole power half. So listen carefully. Yeah? There is no formula for x square plus 1 whole power of directly. This is your function g of x. So this is what you should see always. This is looking like what? This looks like x power n. But it is not x power n. It is something inside to the power of half. Are you getting it? This looks like x power n. So x power n ka formula is what? Half into n into x power n minus 1. But whatever is inside is not x. So you have to differentiate that again. I hope you're getting that logic behind that. Now, if you just expand this, that would be half root over x square plus 1, because that is minus half. And this differential will be x square ka differential is 2x and 1 ka differential is 0. 2 will cancel x by root over x square plus 1. Please have a look at these three examples. Ask me if you're confused, like, anything that you're not that clear with it. We'll do more examples. I'll give you more examples and we will do some more. So in differentiation, right, this is the final level.
Sir, can you please explain the working again, that 1 by 2 root x square plus 1?
So this is looking like x power n, right? So what is the formula for this? N into x power n minus 1, no?
Yes, sir.
This is looking like n, isn't it?
Yes.
So that is n into x power n minus 1. And whatever is the function inside, differentiate that. Make sense? Yeah. All clear with this? Let me take a few more examples. Let me take something more complex. Let's say d by dx of sine of cos of x cube. Sine cos x cube. So this is f of g of h of x. Three functions this is. It's a triple nested function. So how we do this thing? So listen, first of all, this is the function. So this is sine of something. This is how normally you can say sine of something. So sine of something, sine ka differential is what? Cos of something. That is cos of that something is cos x cube. Differentiate that something, that is a function. Differentiate the function dy dx of cos x cube. And now this thing is again looking like another cos of a function inside. This is again another template differential. So this will be cos of x cube. Just keep this aside. So this is cos of something which is minus sine of function, and then differentiate whatever is inside. You just keep differentiating till you get your x. So this will be minus cos of cos x cube sine x cube 3x square. You will never see anything like this in physics. I'm just giving you to show you like how we do this. You keep differentiating till you get the standard function. Have a look at this.
So can
You're
you
getting what I did?
switch to the previous slide for once?
Yeah.
Yes, sir. Thank you.
Great. So let's take some examples. That's the best way to do. You'll get the hang of it. But I hope everyone got the basic idea there. So first thing, what is step one? Look at the function and see this thing looks like what? This should look like something of your standard, the 6 formulas we have. It should look like something of this. Sine of something, cos of something, e power something, x power something to the power of n. It looks like something. And then whatever you get, differentiate that again. So let's take some examples. So d by dx of sine 2x. Give it a try. Just try. I'll show you the answers, then we can verify and see if it's right or wrong. All these functions, right? You'll see in physics. So I am just teaching you what is required only for physics. We are not a maths class. We will not do anything else. Let's get it. Try all of them. Don't think, just put it whatever you think. And I'll show you the answers, then you can see what went wrong. Right. Try. Everyone try. I'll give you a minute or two. Just don't think so much. Look at the function. It looks like sine of something. Sine ka differential is cos of something, and then differentiate the something which is inside. So something is the g of x basically. Palak, Shreyansh, keep your cams on.
Yes.
The exam is online till Friday, huh? So make sure to give it. I know some of you messaged me regarding some issues, so we will discuss them, at the exam get over, because some people are yet to give the exam. We will discuss them in the next class. Okay, someone type the answers. Okay, let's see the answers, each one. Look at the first one, sine of a function. So this is your function. So sine of something. So sine ka differential is cos of something. Then differentiate whatever is inside. That is that function 2x. So differential of 2x will be 2 into dx by dx, 2 comes out. So cos 2x into 2. Please check. Ask me if you're confused. If you didn't get, ask me. I'll just explain you again if you're confused. So this is cos of something. So minus cos ka differential is sine. Minus sine kx. Then differentiate whatever is inside. Remember, k is a constant. So k into x, k comes out. Dx by dx is 1. I'll write that for you. Minus sine kx into k dx by dx. That becomes 1. So minus k sine kx. This thing can be written as d by dx of sine x ka whole square. So this is looking like x power n. You're getting it? It looks like x power n, but inside it is not x. Looks like x power x square. Looks like. So what is the formula? N into x power n minus 1. So 2 into something, the function, 2 minus 1, and then differentiate the function inside. So that would be 2 into sine x, and sine x ka differential is cos x. 2 sine x cos x is sine 2x, trigonometry. Please check. Any doubts on 1, 2, 3, please ask.
So can we not, write sine square x as sine x into sine x?
You can do that, right? But what happens if I give you sine power 7x?
Ah,
Then it becomes a difficult. Now I'm just showing you something easy, nothing much. So this will be working better even for much complex functions.
okay.
How is sine 2x is sine x? This is sine square x, na? That's not sine 2x. That is sine square x. That is sine x ka whole square.
Sir, but if we then put sin x into sin x and then put the product rule, will the answer be the same?
Same answer, na? Last time kiya tha, check karo.
Yeah. Yeah, it will be the same.
Last time sine ka kiya tha, wahi tha sine 2x.
Mhm.
Monica, still, where are you confused? How is sine
But I
2x?
was not understanding how sine square x is going to be sine x the whole square.
This is, that is a way of writing it. Sine square x and sine 2x are totally two different things. So this is sine x into sine x is called sine square x. Sine of 2x is sine of 2 times the angle.
No, sir. I was okay, sir. I got it, but I was telling something.
Okay, what you're telling?
I was just confused how we got that as the one function.
So- You're confused from here to here?
No, sir. I got it.
Sure?
Yes.
Okay. What about the other three? So cos square x will be that will be, this is dy dx of cos x ka whole square. So that can be written as 2 times cos x differential of cos x, which will be minus sin x. So minus 2 cos x minus sin x. So that will be minus 2 sin x cos x, which is minus sin 2x. If you check it out last time, we got the same answer there. That is for D. What about for E? This looks like sine of a function inside. So this whole thing is g of x inside. So sine of something, sine ka differential is cos of that function, and then differentiate whatever is that function inside. Remember, pi is a constant. So this will be pi by 3 into dx by dx, and pi by 6 ka differential is 0 because it's a constant. So pi by 3 just comes out. This is a pretty common differential, E and F. We will see this in a chapter called waves and SHM a lot. It comes a lot. That's E. What about F? F is the same thing. It is cos of something. So it will become minus sine of pi by 2x plus pi by 3, and differentiate inside, you get a pi by 2. Please check your answers. I think if you got till here, I think your differentiation is cool. Have a look at this. Let's do a few more examples and then we will see something more. Any doubts on this? Anyone didn't understand till F, A, B, C, D, F? Anything you're not clear, please ask. Ritu, clear, na? Maulika, Venkatesh,
Yes.
Abhinav, Arjun, clear?
Yes, sir.
Vidyut, Palaksh, Shreyansh?
Clear, sir.
Yeah, Shreyansh, do adjust your cam so that I can see your face completely. Do keep your cam so that your face is visible. Let's see a few more examples. I'm turning the page. d by dx of root over x cube plus x. These are some of the most common things we will see. Sin 2x का whole cube. Let's get these three. How do we do this? So this is d by dx of x cube plus x whole power half. So this is looking like function to the power of half. So the formula is n into, that is half into the function to the power of half minus 1, and then differentiate whatever is the function inside. Half minus 1 is minus half, so it comes into the denominator. 2 root x cube plus x. X cube ka differential is 3x square and x ka differential is 1. 3x square plus 1 by 2 into root over x cube plus x. Check. Any dots on the G part? H will be d by dx of sine 2x ka whole cube. So this can be written as 3 into sine 2x whole power 3 minus 1, and then differentiate whatever is inside. That will be sine 2x. That would be 3 sine square 2x, and sine 2x ka differential will be cos 2x. And then don't forget, you have to differentiate whatever is inside again. So this is a triple function actually. You have to keep on differentiating till you end up with dx by dx. So this guy would be 3 sine square 2x cos 2x into 2. Check your answers.
So we could have directly taken the derivative that we calculated for sine 2x in the last.
Yeah, we could have done that, but we are under the assumption we are doing everything for new.
Yeah, but once we get used to it, we can directly start.
We can do that. We can do that. Get the I part, everyone. What is the answer for the I? Let's see this. D by dx of 1 by root over x square plus 1. I can write this thing as x square plus 1 whole
Can
power
you go to
minus
the
half.
previous page for a minute?
Hmm.
Yes, thank you.
So this is function to the power of minus half. So minus half the function minus half minus 1 and then differentiate whatever is the function inside. So that will be minus 2. That will become x square plus 1 whole power 3 by 2. And that's 2x plus 0. 2 will go off. So you end up with minus x by x plus 3 by 2.
So we can use u by v rule, right?
You could have done that also. But again, when you do u by v, so you have to differentiate x square plus 1 ka root, no? You'll get a chain rule again. Chain rule will come compulsory. Doesn't matter. Get this J1. This will come in current electricity, this differential. How do you do this thing? This you have to use f of x by g of x. And in that you get a chain rule again. Minus 1 by 2 x square plus 1. Yeah, it's little complex. It's not a straightforward one. So you can take this as f of x. I'll do one thing. Actually, I don't like u by v formula. X into, I'll write this as x square plus 1 whole power minus half. I will use the product rule. F of x, nothing wrong. You can do that also, you'll get the answer. But for some reason, I don't like the division rule. So this can be written as, so when you differentiate one, the other guy will just be outside. So x square plus 1 whole power minus half, differentiate f of x. And remember, like I told you last time, this is all maths. No one will ask you like this in physics. The applications will be quite different. You'll see that. And this will be f of x into differential of x square plus 1 whole power minus half. That will be 1. This will be n into, that is minus half into x square plus 1 whole power minus half minus 1, and then differentiate whatever is inside. This will be 1 by root over x square plus 1 minus x by 2 x square plus 1 whole power 3 by 2, and that differential is 2x. So 2 goes off. Minus x square by x square plus 1 whole power 3. Check. These things do come. Physics may, this thing looks big, but these kind of things do pop up. This much level of differentiation you should be comfortable with. In actual max class, they will teach you much more dangerous things than that. Meaning, when the max people actually teach you, right? This will be like a small puppy. They'll teach you a Godzilla. Yeah, if you compare, that is how it looks. But yeah, for us, this much level of differentiation, you're comfortable. I think we have sufficient for physics. Just let me give you one more example and then we'll go ahead. Today, primarily, we will see how to use differentiation in motion, acceleration, velocity, all that stuff. Next class, we'll do maximum, minimum. Any doubts on this J1? Clear, na? Adit, Abhinav? Let's say if I have d by dx of e power minus 2x cubed. What about this guy? I just lost Wi-Fi. Today now we'll have a little issue only. Yeah, hope everyone is able to hear me. Just give me a minute. So let's see the answer for this thing. So this thing is e power something. So this is e to the power of minus 2x cubed, the whole function. And then differentiate whatever is inside. That would be x cubed will be 3x squared. So the 3 into 2 is 6. Hope this was clear. Then what about this thing? This is ln of a function. This will be 1 by ln ka differential is 1 by x, and then differentiate whatever is inside. So 1 by 2x plus 3 into 2. Check. I think if you have got till here. Yeah. Clear for this? Next one. 1 second. Just turn my Wi-Fi. Next thing, differentiation of a vector. So there, with that, the basic mathematical part of calculus is done. So now we're going to combine vectors with calculus. So when you differentiate a vector, what you do exactly? Let's say you got a vector a bar, which is ax I cap plus ay j cap plus az k cap. So the differentiation of a vector dA by dt, you simply differentiate each component. Ax, the vector will remain same, I cap, dy dt ay, daz by dt k cap. So it's pretty straightforward. Example, let's say a bar is t cube I cap t square j cap plus t k cap. So if someone asks you to differentiate dA by dt, this is simply d t cube ka differential I cap. This is t square ka differential j cap, and this is t ka differential. Like I said last time, every time you do not differentiate with x only. You can differentiate any quantity with any other quantity. This would be 3t square I cap plus 2t j cap plus k cap. Do have a look at this example. All clear about this? Great. Can I turn the page?
So just a minute.
Yeah. Clear, right? Go ahead. Yeah. So now where do we use this exactly? First thing, right? If you have r bar is the position vector. We have studied this in vectors. So we define velocity vector. V bar is rate of change of position vector. So if you differentiate a position vector, you get a velocity vector. So we can get acceleration vector. A bar is nothing but dv by dt. So if you differentiate velocity with respect to time, you get acceleration. So acceleration can also be written as dv by dt You can write this as dr by dr. This quantity dr by dt becomes velocity. So the formula becomes v dv by dr. So basically acceleration has two formulas, huh? So acceleration vector is dv by dt. Use this when a is given in terms of time. V dv by dr. Use this when a is given in terms of position. So let's see how to use that. All copied? Great. Let's see our question. Run in the page. Last time we did something like this. T cube by 3. Pi t square by 2 plus 6t plus 1. So find velocity, acceleration, find velocity, find acceleration when velocity is 0. That's the first question. Second thing, find distance traveled. Did I give the same numbers last time? No. In 4 seconds. Let's get this thing. X is a position or X coordinate. Okay. Seven and minus 7.
So a quadratic is coming now.
Yeah, you'll get a quadratic now. So you'll get two roots. So you'll get two answers for the first part. But I didn't expect a 7. Maybe. 3 and 2, 6 and -1. Wow. Not a single one of your answers are matching, right? 4 people get 4 different answers. Aditya says ±1, Ronak says ±7, Venkatesh got -3 and 7, Mehan got 3 and 2. -1 +1, Ajrit. 2 people gave +1, -1. So what to do for the first part? What is velocity? Differentiate. This will be t cube ka differential is 3t square. 3t square by 3. 5t square ka differential is 5. 2t by 2. 60 ka differential is 6 and 1 is 0. Like I said, we'll be skipping writing like this later on. You should get used to it by now. This is your velocity. So if I differentiate this again, dv by dt for acceleration, I end up with 2t minus 5. So the question is, find the acceleration when velocity is 0. So v t square minus 5t plus 6 is 0. We get two roots, 2 and 3. So indirectly the question was, find the acceleration at t is equal to 2 and t is equal to 3. So t is equal to 2 minus 1. T is equal to 3 plus 1. Check. So you have to just put t is equal to 2 and 3 in the acceleration cut term, and then you get the accelerations from there. Do have a look at this. See where you guys went wrong. Ronak, how did you get 7, right?
I took
Did
the
you take
roots
this as
yeah, I took
plus,
the roots
yeah?
as -6 and +1.
Messed up the roots. Have a look at this first part, everyone. Easy one. Get the distance. That's a good one. Last time I told you how to find the distance traveled. Find the distance traveled in 4 seconds. Distance, everyone. Do you guys remember how to do the distance part? Whenever they ask you find distance, it's a trap. Mostly it's a trap. The particle is turning, whenever you get velocity 0, the particle is actually making a turn backward. So here velocity is 2 and 3. V is 0 at t is equal to 2 and t is equal to 3. So the motion is something like this. X is t cubed by 3 minus 5t squared by 2 plus 60 plus 1. So this is what's happening. The particle turns back at t2 and t3 0. So first thing, at time 0, t is 0, x is equal to 1. So you're starting somewhere here. At t is equal to 2, where are you? At t is equal to 2, x is equal to 8 by 3 minus 10 plus 12 plus 1. 13 minus 9, 3, 3, 9 plus 8, 17 by 3. T is equal to 3, where are you? So this calculations now. 3 cubed by 3, that is 9 minus 9 5 45 by 2 plus 18 plus 1. That is 28 minus 22.5. That's 5.5. At t is equal to 4, where are you? You literally have to calculate for each one. That is 4 cubed by 3, 64 by 3 minus 40 plus 24 plus 1. I hope I'm right. That would be 64 by 3 minus 15. So 19 by 3. Perfect. So this is what is happening. T is 0. You're at x is equal to 1. Then you have gone straight. T is equal to 2. You're at x is equal to 17 by 3, which is how much is this? 5.66. Isn't it? Yeah. And this guy took a turn back at t is equal to 2. Understand? This is actually happening all on the same line. For you to understand, I'm drawing a curve. Then you're going back till here, and then again you're taking a turn, and then you're going front. This point is t is equal to 3, and your position is 5.5. This is t is equal to 4, and your position is 19 by 3. Please check. If they ask you to find the distance, there is no other way but to actually plot it on, for each part you have to plot and you have to find. Because if you just find x at t is equal to 4 and t is equal to 0 and subtract, you get displacement. What I asked you is for distance. So you need to find this length plus this length plus this length. So distance will be 17 by 3 minus 1 plus 17 by 3 minus 5.5 plus 19 by 3 minus 17 by 3. How much is that? 20 by 3, yeah? Adrit, did you get the same calculations? How much is that? 17 by 3 minus 1, 14 plus 17 minus, how much is that? 5.53, 16.5, 1 by 6 plus 2 by 3, 16 by 3 plus 1 by 6 and multiply by 2, 32 plus 1, 33 by 6. Weird. 2 plus 1, 33. 11 by 3. No, did I goof the calculation somewhere?
So t equal to 1.
Why t is equal to 1? You're stopping at 2 and 3, right?
नहीं वो नहीं अपने t equal to 1 में distance calculate किया क्या?
No, I didn't calculate a t is equal to 1. I needed to calculate it 0, t is equal to 2, t is equal to 3, and t is equal to 4.
अच्छा, okay, got it.
1 is not there only in the picture. Everyone have a look at this. Is this clear, everyone? Anyone is confused, not clear with this, anything, please ask. हाँ, Maika.
The last part I didn't get it, sir.
Distance के लिए?
Yeah.
See now, you have to add this length. How much is this? 17 by 3 minus 1. You have to add this
Okay,
piece. How
okay.
much is this? 17 by 3 minus 5.5. Then this part, 19 by 3, I goofed up. It is 5.5. This was 5.5. That was 5.5. 14 by 3, and how much is this? 17 plus 19, 18, 18, 36 by 3. So that will be 12 minus 11 plus 1. Yeah, 17 by 3. Adrit, you got it right. I messed up. Please check your answers. The distance part is always complex, huh? That is the lengthiest one. Because literally you have to find each point and calculate, but there's no way out. All clear with this? Next one. Ronak, clear?
Yes, sir.
Abhinav, Swastika, clear?
Yeah.
Turn in the page. Ritu, Monica? Perfect. Next one. Same thing. Let's say x is equal to some k into 1 power 1 minus e to the power of minus bt. K and b are constants. Find initial velocity and find acceleration. All these are questions based on motion and calculus. Vectors still not come. What do you mean by initial velocity? When you hear the word initial, meaning he's saying time is 0. That is the meaning of that. Keep that in mind. If someone asks you find the initial velocity, initial position, he's simply telling you put t 0 and get the answer. So first to differentiate and then put t 0. Try this. 2 minutes. This kind of things that we encounter in viscosity and frictions, air resistance ka problems. And minus kb, okay. So first thing, for velocity, you differentiate. So this is simply k, and when you differentiate, right, k just comes out. D by dt of 1 minus d by dt of e power minus bt. So this guy k into 0 minus, that is e power something, e power function. So that will be e power function, because e power x is e power x only, and then differentiate whatever is inside. This is e power function. This is minus k into e power minus bt into minus b. So this is kb into e power minus bt. This is your velocity. You want acceleration, differentiate dv by dt. That will be k into b, e power minus bt, then differentiate again that minus b, you will get one more minus b here. So minus kb square e power minus bt. So at t0, velocity will be k into b, e power 0 is 1 people.
So over here, why do we differentiate bt again?
It is not e power x, it is e power some function, right?
Okay.
So chain rule. And acceleration will be minus kb square. Check your answers. Once you got that, you just need to put t0 there. Do have a look at this. Ask me if you're confused. Right, Yasha. Initial velocity is right. Aditya, you messed up the acceleration part. Both you messed up actually. Ronak, you messed up the acceleration part.
It is kb square only. That square cannot be written that way.
Okay, ऐसा है क्या? ठीक है. All clear with this? Can I turn the page? Any doubts on this? Anyone not clear with this? Triyansh? Clear, right? Next one. velocity v is given by t square plus t. Velocity v is given by root over x square plus x. Find acceleration. Be careful here. V is velocity and t is time here. Your x is position. Find the acceleration in both the cases. One by two, 2t plus one. Okay. Let's see. You got such a good answer. There is a root also there. Chain rule, people. T square plus t whole to the power of half. It is something to the power of half. T by root over t square plus. Numerator में 2t plus 1 come, right, Ronak? Numerator में 2t plus 1 will come. See, look at the first part. Acceleration dv by dt. This is nothing but d by dt of t square plus t whole to the power of half. So we are using chain rule, something to the power of half. That will be half into the function t square plus t half minus 1 and then differentiate the function which is inside. I'll send you a practice sheet on this chain rule and all this stuff, so make sure to do it. So this will be half into that guy comes the denominator root over t square plus t minus half, that is, and that will be 2t plus 1. Check. See where you guys goofed up. No, you won't get 2 in the numerator. 2t plus 1 it is. And this 2 won't get cancelled. Check it out. 10a. Anyone has a doubt on that, please ask me. What is the difference between A and B? Ritu, what is the difference between A and B?
Sir, when
Ah,
I'm
Mike.
directly doing with root, I'm getting different answer.
Directly meaning what are you doing?
Like differentiation of root x would be 1 by 2 root x.
But where is root x 1 by?
No, like directly.
Differential root x is 1 by 2. Why you can't? 1 by 2 root x. Then differentiate that inside thing na again.
I'm getting different answer.
If you differentiate this inside, this will be 2t plus 1 only. Na?
Yeah.
What you said is right only. Then you messed up that you have to differentiate the function inside.
I did, sir, but then I guess I did the calculation part wrong.
Yeah, check it out. Ritu. So what is the difference between the A and B part? I can't hear you, right? Meaning mic is on mute or I still can't hear you. Do check out, see what happened. Niranjan, what is the difference between A and B part?
So for the B part, I got 2x plus 1 by 2.
Now what he came, but what is the difference?
Sir, in this, the position is given, so we will use BdV by dr.
So formula change ho jayega. So because time is given, they use this, position is given, use this. So the formula has to be different, be careful. So in this case, the formula has to be V dV by dx. Right, Ritu? So first thing you have to do dV by dx. that will be same as this. Only difference will be 2x plus 1 by t ka place mein x will come. So just multiply with v into dv by dx. That will be root over x square plus x into 2x plus 1 by 2 into root over x square plus x. This will cancel. 2x plus 1 by 2. Check. I still can't hear you, right? There's some issue with your mic, I suppose. Others are able to hear me, right? Then check it out, na, Ritu, later on what happened. But got this thing, na? Ritu, clear, right? Yeah. I hope all got the difference between A and B. Be careful, the formula will change completely. When you are in time, use dv by dt. In position, use v dv by dx. So the dv by dx ka term will look similar. In place of t, you will get x, but you have to multiply extra v there. Most people go up there. If I give you v in terms of x, they do this. I know it looks simple, but in the exam hurry, right? People do all kind of mess ups. My favorite mistake is 3 into 3 is 6. I don't know why. I did that at least 6 to 7 times in 11th and 12th. I did that in the final chemistry paper also. And the sad part is I remember. All clear with this? Any doubts on 10th, please ask. So if you see chain rule, right, this is how they'll ask you. No one is actually interested in the chain rule, but velocities, accelerations, and all these kind of stuff will keep popping up. Clear? Next one. Next one. Let's say we have a velocity vector. V is equal to, let's say r bar is t cube by 3 I cap plus 1 by t j cap. Find velocity vector as function of time t. Now see, the way I'm representing is only changing. Here I simply said find v, find a, but here I'm asking find v bar as function of time t, find a bar as function of time t. So I'm asking you a vector. Find a time when acceleration vector is perpendicular to velocity vector. If two vectors are perpendicular, what should you use? If two vectors are perpendicular, what is the first thing that comes into the mind? What should you use?
Dot product equal to 0.
Dot product is 0. Remember that. Whenever someone says in physics 11th and 12th, right, two vectors are perpendicular. The force vector is perpendicular. The displacement vector doesn't matter. You use the word perpendicular. 99% get the dot product. So there are, in the question, right, there are always clues and words. It's like you have to read between the lines we say, right? It is something of that sort. Whenever you hear the word find distance traveled, become alert. There's a high chance you will go up because distance and displacement are not same. How do you do this thing? Find the velocity vector as function of time t, acceleration vector as function of time t. Find time when the acceleration vector is perpendicular to the velocity vector. Try everyone, 2-3 minutes. Everyone should try. It's okay to get a wrong answer, but try. Don't wait for me to give the answer. Try, mess it up. That's totally acceptable. That's how you learn fast. How do you do this? Now we are differentiating vectors. This is how it will go. Every chapter that I teach you will keep on piling up. We did vectors. We used trigonometry. Then we did vectors. We used trigonometry and vectors. Now we are using calculus and vectors. Next chapter, kinematics, we'll use everything, and so on. So when you're doing even 15th chapter, you will use everything from chapter 14 to chapter 14. What is the velocity vector? Differentiate. So t cube ka differential is 3t square. 3 will cancel. T square I cap. 1 by t ka differential is minus 1 by t square j cap. Check. Confused, ask me. What is acceleration dv by dt? You should get used to it. Huh? You can't keep writing every time, every simple form. T square differential, 2t I cap. This is t power minus 2. So yeah, you can write for this. That will be minus 2, t to the power of minus 2 minus 1 j cap. 2t I cap plus 2 by t cube j cap. Check. And you said the two vectors are perpendicular. Since they're perpendicular, a bar dot b bar should be 0. How to do dot product? Multiply the I components, j components. That is t square into 2t minus 1 by t square into 2 by t cube is 0. 2t cube is equal to 2 by t power 5. T power 8 is equal to 1. T is equal to 1. 1 second. Check. You got a good answer.
Sir, I got lost for a second. Can you just repeat?
No, I was just saying we have just differentiated, right? So I differentiated r bar, I got velocity. I differentiated velocity, I got acceleration. Right, Monica?
Sir, I got 0, like t square I cap minus 0.
E 1 by t ka differential, right? That is t power minus 1.
Okay,
Na?
okay, okay. Yeah.
That
I
should be
just
minus
did
1
one.
into 1 ka nahi karna hai. T power minus 1 differential is what? Minus 1 t power minus 1 na? 1 by minus 1 by t square.
Yes, sir, got it.
Easy, everyone. But the question in the exam will be find the time when a bar is perpendicular to b bar. Check. Ask me if anyone is confused here.
So alternatively, we could also find out the value at which t is in the velocity ka thing. We just solve that for 0, right?
You can't put 0. How will you put 0 here?
Like by hit and try, we'll get it now.
No. See, if you put 0 also, how would you get here? I cap and j cap will never cancel, na?
Oh yeah.
These are vectors. This is not a normal thing, na? Yeah, they'll never cancel. Yeah, sure. You got that acceleration part wrong. You got a minus sign, na? Plus आना चाहिए. Minus or minus become plus, na? All clear with this? Perfect. Can I turn the page? Abhinav, Swastika, clear, na? Rehan? Clear. Ritu? Clear? Maulika? Palaksh? Perfect. 12th one. Let's say we have a position vector r bar, which is cos 2t I cap plus sine 2t j cap. Find angle between r bar and acceleration vector. R bar is position vector. T is time. R bar is given. Find acceleration vector and then find the angle between acceleration and r bar. Get it? So first find velocity, then again differentiate, get acceleration. Someone asked you to find the angle. Indirectly, again, he's telling you to use dot product. R bar is cos 2t I cap, sine 2t j cap. Try everyone. Next class will be more fun. We'll have more applications. We're still in the max region only. Even though we're using little of motion, but it's mostly max. Next class we'll do maxima minima. There we'll find more interesting applications. Any answers? I'll give you a minute more. Try, Ronak, try. Palak, just your cam. I can't see your face. Monica, same thing with you. Venkatesh, you need to adjust your cam. Shreyash, you are keeping your cam off. I will remove you from the classroom. So do keep your cam on. Unless if there is some issue, you can just leave a message. And you can keep your cam off. I don't mind. But if you're switching off every 5 minutes, I'll assume you're sleeping. Answers, anyone?
So in this also we'll have to double differentiate.
Ah, obviously, no?
Yeah. So first thing, how do you find velocity vector dr by dt? So I'll write the answers directly, but you ask me, if you're confused, you didn't get that, you ask me, I'll show you in detail. So cos 2t ka differential, that will be sin 2t with a minus sign. And you have to differentiate 2t again, so one more 2 will come, to minus 2 I cap. Sin ka differential will be 2 cos 2t j cap. You should be this comfortable. Matlab, you see the differential, you can start writing. I don't want you to keep writing each and everything. Starting, it's okay when you're learning, but eventually you should be this comfortable. A is dv by dt. So when you're differentiating sign, you get a cos 2t and one more 2 will come out. So minus 4 cos 2t I cap, and cos ka differential will be sin minus, so minus sin 2t j cap. Please check. Anyone didn't get this a bar and b bar, please ask. And then you're asking me to find the angle between a bar and r bar. So a bar dot r bar is mod r bar cos theta. So first do the dot product. That will be minus 4 cos square 2t minus 4 sine square 2t, and mod a bar will be magnitude of this vector, which is root over 4 square cos square 2t, 4 square, that is 4. Magnitude of r bar is 1, and that is cos theta. And this is minus 4 is equal to 4 cos theta. Cos theta is equal to minus 1. Theta is equal to 180 degrees. Check.
So that is A dot R, right?
A bar dot r bar, no? Because our question is between a bar and r bar, no angle.
Yes.
You don't need velocity as such, but without velocity, you won't get acceleration ka term. Please check everyone. I skipped a lot of steps. Anyone not clear with any particular thing here, please ask. I hope you're seeing how we are using chain rule, how we are using, motion, velocities and acceleration and vectors. Things will get combined like that. And no one will just ask you the chain rule. Any doubts on this? Anyone not clear, not convinced? Malika, clear? Malika, got this? Ritu? Priyansh? Priyesh? Perfect. Abhinav, clear now?
Yes.
Next one. So we got a circle here of radius r.
x-axis, y-axis, and this is origin. So we have a particle here starting from here with speed u. Means initially it is at r comma 0. So a particle goes in a circle of radius r with speed u. Find the position vector as function of time t. Find velocity vector as function of time t. Find acceleration vector as function of time t. I hope the question was clear. Initially, the particle, right, starting at r comma 0, it's going in a circle. So after time t, it will be somewhere here. I want you to find the position vector, the velocity vector, and the acceleration vector as function of time t. Check. And in case you're wondering about the position vector, I'm sure we have done this. Do you remember this question? Particle is going in a circle. I taught you how to find the velocity vector and the position vector. So we did something of that sort. Try. Right, Adrit, those are the coordinates, no? But what is theta? Theta, I didn't give you. If I know these coordinates, theta, my job is done. R cos theta I cap, R sin theta j cap. But what is theta? Theta is not given. You have to find theta. What is given is the speed and the radius. Think it's a good one. I'll give you a minute or two. 1 minute for position vector. This is a pretty good question. It comes in circular motion again. And there's something I want to teach you based on this, and I'll show you something pretty nice after this. Anyone got the angle as function of time t? Right, Aditya. In time t, how much do you travel? If you're going with speed u, in time t, how much will you travel? Anyone?
UT.
UT, right? This is the distance traveled. So this will be the arc length. And this is the radius. This is theta. So what is theta? Theta is arc length by radius. Which is nothing but UT by R. There. That is how you find the angle. Got it? So let's say after time t, you're here. This was your R bar vector. That means on this circle, when it is here, R bar, this coordinates will be R cos theta, comma R sin theta. I hope everyone is okay with that. I just dropped a perpendicular. R cos theta, and the opposite side is R sin theta. So we get R bar will be R cos theta. Theta is UT by R. I cap R sin theta, which is UT by R j cap. Please check. That's your position vector function of time t. So depending on the time, the theta will change. The theta can be like this also. We don't know. The science will take care of it. You don't worry about it. Whenever you solve problems, always assume theta is acute. and solve, the theta will take care of it because it's a variable. Please ask me if you're confused here. Most people have a problem finding the theta. That is actually the arc length by radius, and arc length is nothing but the distance traveled. How do you find velocity? Differentiate this. You want velocity, differentiate this. I'll show that in the next page, but try. I'll give you another 1 to 2 minutes for velocity and acceleration. Remember, u and r are constants. If you got the position vector, find the velocity vector and find the acceleration vector. You will see something you will see something you know here. More than that, I wanted to show you something else in the next problem. I'll show you how an advanced question will be framed. None of these are advanced questions. Till now, what we did, none of them are advanced. All these are mainstream, easy to moderate stuff. Like I said, calculus and vectors and all, you can't really ask anything advanced stuff. What is the velocity vector, everyone? Don't worry, if you're finding this little difficult, that is because you're not used to it. You'll become strong. All this stuff after 3 months, it'll look like a joke. But it takes time. Adrit, you messed up. No, I think you are right. Get the acceleration part also.
It is actually UT by R.
I know, I got your point. I understood. Unable to type everything. That's okay. T by R, I cap. Okay. So what's the velocity vector? dr by dt. So R cos ka differential will be minus sine ut by R. And then you have to differentiate whatever is inside. So you have to differentiate ut by R. I cap. Plus R cos ut by R, and then differentiate whatever is inside. J cap. So ut by R, that is u by R just comes out. That will be minus u sine ut by R I cap plus u cos ut by R j cap. Please check your answers. You want acceleration, differentiate the velocity vector now. So basically, every time you differentiate, one u by R will come out. Huh? That was the idea there. Because it is sine of something. So that function inside has to be differentiated. So if you differentiate this again, you will get a minus u by R, and sine becomes cos ut by R. Cos will be minus u by R. This will become sine ut by R. J cap. So this turns out to be minus u square by R cos ut by R I cap plus sine ut by R j cap. And if you see this is nothing but minus u square by R. This is R cap. This is unit position vector. And did you observe something acceleration ka term? This is also called a centripetal acceleration. When a particle is going in a circle with speed u and radius r, the centripetal acceleration is u square by r towards the center. Isn't this the formula u square by r? And the minus sign indicates it is towards the center, opposite to the position vector. So the centripetal acceleration term is actually derived. It just didn't come out of nowhere. Have a look at this. But in circular motion, I'll teach you in a different way. But mathematically, this is how you can get that acceleration. Do look at the terms. Just let me show you the diagram. Finally, what we got, This is your R bar. This is your velocity bar. And this is your acceleration bar. Did you observe one thing? Every time you differentiated it, the vector became 90 degrees. It is rotating. The vector is rotating every time you differentiate. We observe when R bar is differentiated, it rotates 90 degrees anti-clockwise. Means if I differentiate A bar again, I would have got like this. We will discuss about this, the property of rotating a vector when you differentiate. But do have a look at this first. Any doubts on finding A and R bar, please ask. All clear with this? Any doubts on this? Anyone didn't get any particular term here? Swastika, clear, no? Mehan? Clear. Venkatesh, Niranjan, Ritu, Malika. Great. So what is this rotation of a stuff? So let's take like this. Differentiation of a constant, a vector with constant magnitude. Let me take a unit vector. Let's take it simple and then we can stress it. So the first thing, given unit vector, right? So mod A bar is equal to 1. So this can be written as A bar dot A bar is also 1. Agreed? Because A bar dot A bar is what? Mod A cos theta, theta is 0 because it is parallel. A bar dot A bar is mod A bar and cos 0. This is 1. Now differentiate this. With t or something, doesn't matter. Let's say with time. Now remember there are two quantities here, A bar dot A bar. So we have to use product rule. So d bar dA by dt plus dA by dt dot A bar. On the RHS it is 0 because it is a constant. So we got 2 times A bar dot dA by dt is 0. Tell me one thing, if the dot product is 0, what does it mean?
Perpendicular.
Vectors are perpendicular, meaning A bar is perpendicular to dA bar by dt. So A bar and dA by dB are perpendicular to each other. Now, why is this happening actually? Mathematically, we understood, but if you try to see geometrically the meaning of this, do have a look at this page once. Ask me if you're confused here. All clear with this? Now, why is this happening? Let's see that part. If you try to see this geometrical interpretation,
Well, can you go back for a minute?
yeah.
Yes, so thank you.
Yeah. Now think about it. Let's say if I have a vector A bar, how can you change a vector? You can change a vector by changing its magnitude. So delta A bar parallel. So this will be responsible for changing the magnitude. So whenever you say a vector has changed, you can change by changing the magnitude. Or you can rotate the vector delta A perpendicular. This is responsible for changing direction. You're getting it? So whenever you say there's a change in vector, there are two parts in it. But now here you're saying, if you say the vector can, magnitude does not change. So a vector can change by changing magnitude or direction. Or both, basically. You can do both. Right? But here, what you're saying is, here you're saying magnitude is constant. That was given, right? The magnitude of vector is constant. It's a unit vector. That means the only way you can change the vector without changing the magnitude is what? Therefore, direction only changes. That means it can change only perpendicular to itself. You're getting it? Let me show you on this on a circle. I'll come back to this page again. So just let's listen to this. So imagine we have a thing going on a circle, because on a circle, the radius vector length is constant. So if this is your vector A bar, the only way, see, think about it. The distance between you and me is fixed. Okay, I'm standing here. You're standing here. The distance between you and me is fixed. Listen to the statement. And I am telling you are moving. Means how are you moving? Can you go this way? Then distance will increase. Can you come towards me? Distance will decrease. The only way you can move is what? In a circle, right? You're getting the point. If I say the distance between you and me is fixed, that cannot be changed. But I'm seeing you are moving. The only way you can do that is if you go in a circle. Think about it. You can go away from me, you can go towards me, or you can go perpendicular to me. But the problem with these things are the distance will change. So when you say the vector is changing, but the magnitude is remaining constant, the only possibility you have is, so this is your initial vector. This is your final vector. The length did not change. And this will be your change in vector. 90 degrees. It's a very small vector. So basically, this will be the end result here. So when mod A bar is equal to 1, right, we observe when a vector of, you could have taken mod A is equal to constant, any number, it doesn't matter. I just took 1 for simplicity. And mod A is constant. Magnitude is differentiated. It rotates by 90 degrees anti-clockwise. By anti-clockwise, right hand thumb rule. That will be the positive direction. So meaning, if this is your A bar, this will be d A bar by dt, first differential. If I differentiate again, d square A by dt square, second differential. If I differentiate again, d cube A by dt cube, third differential. So every time you differentiate, the vector keeps rotating 90 degrees. Differentiate again, 90 degrees. Differentiate again, 90 degrees. If you differentiate again, I'll end up with d power 4 A by dt power 4, and so on. This will never stop. I hope this was clear. You can put a star or something. Do have a look at this geometrical interpretation and that circle thing. Have a look at this page. So this is a concept based on differentiation and vectors. So the reason why when you differentiate a constant magnitude, see again remember right now I'm saying a constant vector. A constant vector will be 0. A vector with a constant magnitude, meaning the direction can change, but the vector is not constant. Best example is this. This is a vector with a constant magnitude but changing. See, what is the magnitude of this? 1. But the direction is changing every instant. Any doubts on this page? Have a look at this. Let's see how they'll frame a question based on this concept. So remember that concept. So if you differentiate a magnitude vector with a constant magnitude, the vector will keep rotating anti-clockwise. If mod A is equal to 1, then all vectors will have same magnitude. I'll show you that. Anti-clockwise, think of like this thing. Remember right hand thumb rule? If you rotate anti-clockwise, it's pointing out of the plane k cap. Anti-clockwise is positive rotation, right? If it is a unit vector, after differentiating also magnitude will remain same. We will not go too deep into this. The basic idea I want you to know is when you differentiate, the vector rotates. Because whenever you differentiate, actually the property changes. Position becomes velocity, velocity becomes acceleration. So it's not the same quantity anymore. All clear with this? Let's see how they'll frame a question on this. Turn in the page. Last one for the day. Let's say vector mod r bar is equal to 1. We have dr by dt plus d square r by dt means second differential. D cube r by dt cube, third differential. So on till d13 r by dt, 13 differentials. Come magnitude. What is this? So you took a vector r bar, you differentiate once, twice, thrice, fourth, 13 times you differentiate and added all of them and uska magnitude liya. What is the magnitude of these 13 vectors? First differential, second differential, third differential, and so on. So this is a second differential. This is a 13th differential. Think I'll give you a minute. It's a good one. Now, if you know that concept of that thing which I taught you, it will be quite easy. If you don't know that, this will be weird. Try. Think I'll give you a minute or two. Try this. I'll give you one more. Adrit, you got it right. Any other answers? 0 nere swastika, it's not 0. Think you did some calculation there. Ronak, you also got 1 right. See now, just now I said, right? Let's say if this is your dr by dt, I'll just call it R1, okay, for simplicity. This will be d square r by dt square. So whenever you differentiate, you rotate clockwise, let's call it R2. Means this is R3 and this is R4. Won't they cancel out? The 4 vectors cancels out, right? So a set of 4 vectors will cancel out. Because they're of same magnitude and opposite vectors cancel out. That means similarly, R power R5, R6, R7, R8 also will cancel. R9, R10. So you just need to remove, the set of 4 vectors and you're just left with R power 13. Make sense? So indirectly you're just adding this 13 ka magnitude. This will be 1. Is that clear, everyone? So basically this will give you 0, 0, 0 and 1. Easy? So, but you should know that concept that when you differentiate, it will rotate by 90 degrees. Clear? Next one. Same thing. What if dr by dt, d square r by dt square, so on till d14, 14. What is this? (15) (16). Actually, these are the 4 possibilities you can get. Try this. Root person again, class. Class So what do we do here? So here what will happen if you see a set of 4. 1, 2, 3, 4 will cancel. So on end me you're only left out with 13 and 14, right? And remember, these are 2 vectors of magnitude 1, both are perpendicular. So you'll get root 2. Are you getting it? You can't add 1 plus 1. These are 2 vectors which are perpendicular to each other. So this 13th vector is 1 and 14th vector is 1 and both are perpendicular to each other. Is that making sense? So the resultant will be in the middle. Root 2. You won't get 1 plus 1 is not 2 people. These are 2 vectors perpendicular to each other. It's like I cap plus j cap. This will be 1 and this will be 0. Because this will be 13, 14 and 15. This all will cancel out. Check your answers. So in these kind of questions, right, the possible answers are 1, root 2, 0. Please check. Any doubts on this, please ask me. The B is a good one. It's not 2, it's root 2. Because both the vectors will be perpendicular. Clear? Any doubts on this? So that's the last one for the day. So this week, right, we'll not be having a class on Friday, like I told you last time. It is actually a break for all your seniors. I have come to my hometown also. I won't be available on Friday. So we will catch up again directly on next Wednesday. That will be on 17th. Right, I'll be posting the results on Friday. Saturday, I'll post the results also. So you can try, and Wednesday next week, we will discuss the paper. See, again, I'm telling you, don't worry about the paper. Whatever happens, it is just a practice paper. Don't become emotional about it. Just give it, because the thing is, you guys are not given the paper before any time. You are not used to writing papers.